Hey there, robot fans! Welcome to a world where science fiction is starting to blend with reality. Remember those giant robot suits from Avatar or Pacific Rim? The ones where humans climb inside and control these metal behemoths, piloting them like futuristic warriors? Well, Hyundai's Method 2 is about as close as we've gotten to that sci-fi dream, at least in the real world, and it's turning heads everywhere. This thing is huge. We're talking 13 feet tall and over 30,000 pounds of pure robotic muscle. It's got arms with actual working fingers, and it can even take a few, very careful steps forward, just like in the movies. It's not quite ready to fight giant aliens, but it's an amazing feat of engineering and human creativity. Seeing Method 2 in action is like watching a movie come to life. It's both awe-inspiring and honestly a little intimidating to witness up close. It makes you wonder, are we on the cusp of a robot revolution? Well, hold your horses. Let's break down what Hyundai's robot army is really all about, and what the future might hold. When you think of Hyundai and robots, the first image that probably comes to mind is Method 2. The towering, almost cinematic humanoid robot that looks like it stepped straight out of a sci-fi blockbuster. With its imposing frame, glowing lights, and the ability to mimic human movements, Method 2 has become something of a celebrity in the world of robotics. But while Method 2 grabs headlines and turns heads at tech expos, it's just the tip of the iceberg when it comes to Hyundai's ambitions in robotics. Behind the scenes, Hyundai has been quietly and steadily building an entire family of robots, each designed with a specific purpose in mind. This isn't just about creating cool machines for the sake of it. Each robot in Hyundai's lineup is a response to real-world challenges, from mobility and logistics to customer service and disaster relief. The company's engineers and designers are constantly pushing the boundaries of what's possible, experimenting with new forms, materials, and artificial intelligence to make their robots smarter, more agile, and more useful than ever before. Take Tiger, for example. At first glance, it might look like a futuristic toy, but this small, all-terrain robot is anything but a plaything. Tiger stands for Transforming Intelligent Ground Excursion Robot, and it's built to go where humans and even most machines can't. Imagine a robot dog, but instead of fetching slippers, it's delivering medical supplies to remote villages after a natural disaster, or carrying scientific instruments across the surface of Mars. Tiger's secret weapon is its ability to switch between wheels and legs, giving it the flexibility to roll quickly over smooth ground or climb over rocks and debris when the going gets tough. This kind of adaptability could be a game-changer for search and rescue missions, planetary exploration, and even last-mile delivery in hard-to-reach places. But Hyundai's vision for robotics isn't limited to rugged all-terrain machines. Enter DAL-E, a robot designed to bring a human touch to customer service. Picture walking into a busy shopping mall and being greeted by a friendly, pint-sized robot with a digital smile. DAL-E isn't just a novelty, it's equipped with advanced speech recognition, facial expression analysis, and the ability to provide real-time information and guidance. Whether you need directions to a store, help finding a product, or just a cheerful hello, DAL-E is there to make your experience smoother and more enjoyable. In a world where automation is often seen as cold and impersonal, DAL-E is proof that robots can be both helpful and charming. Of course, no discussion of Hyundai's robotics lineup would be complete without mentioning their take on the quadruped robot, think Boston Dynamics Spot, but with a Hyundai twist. These four-legged robots are designed for environments that are too dangerous or difficult for humans to enter, like industrial sites, power plants, or disaster zones. They can navigate stairs, avoid obstacles, and even perform complex inspections using cameras and sensors. And yes, they've been known to show off their dance moves at tech demonstrations, proving that practicality and a bit of personality can go hand in hand. These nimble bots are all about adaptability, able to switch from heavy-duty tasks like carrying equipment to more delicate jobs like monitoring air quality or detecting gas leaks. Now you might be wondering, with all this cutting-edge technology, how much does it actually cost to bring one of these robotic wonders home? Well, Hyundai is keeping the exact numbers close to the vest, but industry insiders estimate that the price tags for these advanced machines can easily reach into the millions, especially for showstoppers like Method 2. These aren't gadgets you'll find in your local electronics store, and they're certainly not in the same league as your everyday Roomba vacuum. Instead, they represent the bleeding edge of robotics technology, combining state-of-the-art engineering, artificial intelligence, and a vision for the future where robots and humans work side by side. As Hyundai continues to innovate, it's clear that their robots are more than just machines. They're a glimpse into a world where technology enhances our lives in ways we're only beginning to imagine. So why are these robots so darn expensive? It's a question that comes up every time you see one of these massive high-tech machines in action. At first glance, it might seem like they're just oversized toys for engineers, but the reality is far more complex and costly. The price tag on these robots isn't just about their size or the fact that they look cool, it's about what goes into making them work reliably and safely in the real world. Well, imagine building a custom sports car, but instead of an engine, it's got a network of computers, hydraulics, and sensors. Every single component has to be engineered to perfection, because there's no room for error when you're dealing with machines that can weigh several tons and perform incredibly precise tasks. Unlike a car, where you can buy many parts off the shelf, these robots require custom-built everything. Motors, actuators, wiring, and even the tiniest screws are often made to order. The complexity is staggering, and the cost of sourcing and assembling all these parts quickly adds up. Then, multiply that complexity by 1,000. Each robot is a unique blend of mechanical engineering, electrical systems, and computer science. The sheer number of moving parts, sensors, and processors involved is mind-boggling. And because these robots are often designed for tasks that have never been automated before, every new model is a leap into the unknown, requiring extensive trial and error. These robots are built from the ground up, with parts and software designed specifically for them. There's no instruction manual or kit you can buy online. Teams of engineers spend months, sometimes years, designing, testing, and refining every aspect of the robot. The software that controls them is just as specialized, often written from scratch to handle the unique challenges of each machine. This level of customization is essential for performance, but it also means higher costs at every stage. There's just no off-the-shelf solution for a 13-foot-tall mech suit. When you're building something that's never existed before, you can't just order parts from a catalog. Every piece, from the frame to the smallest circuit board, has to be designed, tested, and manufactured specifically for that robot. This process is not only time-consuming but also incredibly expensive, especially when you factor in the need for specialized manufacturing equipment and facilities. We're talking lightweight alloys, super strong composites, and cutting-edge sensors. These materials are chosen not just for their strength, but for their ability to keep the robot light enough to move efficiently. The metals and composites used are often the same ones found in aerospace engineering. Think titanium, carbon fiber, and other exotic materials. And the sensors? They're some of the most advanced in the world, capable of detecting minute changes in pressure, temperature, and movement. These materials don't come cheap, but they're absolutely essential for performance and safety. When you're building a robot that might be lifting heavy objects or working alongside humans, you can't cut corners. Every material is tested and retested to make sure it can handle the stresses of real-world operation. Safety is paramount, and that means investing in the best materials and the most rigorous testing protocols available. And these robots aren't just remote-controlled puppets. They're designed to operate autonomously, making decisions on the fly and adapting to their environment. This level of autonomy requires a whole new layer of complexity, both in hardware and software. The robot has to be able to sense its surroundings, process information in real time, and respond appropriately, all without human intervention. They need advanced artificial intelligence to walk, interact with their environment, and even learn. The AI systems powering these robots are at the cutting edge of technology, using machine learning, computer vision, and advanced algorithms to interpret data and make split-second decisions. Training these systems takes enormous amounts of data, computing power, and expertise, all of which add to the final cost. Developing and integrating that AI is a major expense. It's not just about writing code, it's about building a system that can handle the unpredictable, chaotic nature of the real world. That means countless hours of programming, testing, and refining, often by teams of highly specialized engineers and scientists. And because the technology is evolving so rapidly, there's a constant need to update and improve the software, which means ongoing costs long after the robot is built. And let's not forget about research and development. Every breakthrough in robotics comes from years of experimentation, failure, and iteration. The R&D process is expensive, requiring not just money, but also time, creativity, and a willingness to take risks. For every robot that makes it to market, there are dozens of prototypes that never see the light of day. Hyundai has poured countless hours and dollars into perfecting these robots. Their teams work around the clock, pushing the boundaries of what's possible in robotics. From initial concept sketches to the final assembly line, every step is meticulously planned and executed with an eye toward innovation and reliability. All those prototypes, tests, and refinements really add up. In the end, the high price tag reflects not just the materials and labor, but the years of expertise, innovation, and relentless pursuit of perfection that go into every single robot. That's why these robots cost a fortune. But it's also why they're at the cutting edge of technology, ready to change the world. Okay, so Hyundai's robots are cool, but are they actually useful? That's the big question everyone's asking. We've all seen the flashy videos and the jaw-dropping demos, but when it comes down to real-world impact, things get a bit more complicated. Are these machines just high-tech showpieces, or are they on the verge of changing how we live and work? The answer is, it's complicated. On one hand, the technology is advancing at a rapid pace, and the possibilities seem endless. On the other, there are still plenty of challenges to overcome before robots like these become a part of our everyday lives. It's a classic case of potential versus practicality.